Okay, we have a problem that asks what sum of multiples of vectors v1 and v2 equal to xy, where v1 is a vector 1, 1, and v2 is a vector 2, 1. Okay, so what sum of multiples of these is equal to xy? Well, the sum of multiples of v1 and v2 is c1 v1 plus c2 v2. So vectors of the form c1 v1 plus c2 v2, where c1 and c2 can be any numbers. Okay, any scalars. Well, this translates into this very clearly, and this translates into this matrix equation. So the condition that a sum of multiples of v1 and v2 be equal to xy translates into this column make up a matrix which, when multiplied by c1, c2, gives you xy. What are these columns? They're the two vectors. They're the vectors v1 and v2. So we could, and you'll see this in subsequent work. I'll just kind of insert this lightly. This is the matrix v1, v2, where v1 is the column vector v1, the 1, 1 vector, and v2 the column vector 2, 1. So this makes perfectly good sense out of this. And this is multiplied by c1, c2, and this should then equal xy. So just a very informative, shorter notation for this is this. This is the vector, the matrix whose columns are the vectors v1 and v2. And again, you can verify that this equation is equivalent to this equation. How do you solve this equation? Well, you simply invert this. Now, it's not going to work if these vectors, these columns aren't independent, linearly independent, because if they're linearly independent, it means that one column's a multiple of the other, and that's going to cause the determinant to be 0. The matrix will be singular. It won't be invertible. And if the matrix is invertible, then that does mean that these columns are linearly independent. In any case, the solution to this, if it exists, is of this form. And the solution does exist as long as this matrix is invertible, as long as the two vectors v1 and v2 are linearly independent. Okay, so we have this. Now this says that c1, c2 is the vector xy expressed relative to the basis b equals 1, 1, 2, 1. What do we mean by that? It means that you do c1 times the first vector in the basis plus c2 times the second vector in the basis, and you get your xy. That's c1 and c2 are the scalars that multiply by the first and second vector in the basis to give you xy. And in that sense, then, we can say that c1, c2 is the expression of the vector xy relative to the basis b. So c1, c2 with a b, subscript b, means that whatever the vector is, you obtain it by multiplying c1 by your v1, your first vector in the basis, and c2 times the second vector in the basis. So again, c1 times the first vector in the basis plus c2 times the second vector in the basis is equal to the xy vector. Okay. And again, c1, c2b means c1 v1 plus c2 v2, and that is your vector xy. And you simply have to understand this. Okay. And the key is this matrix whose columns are the basis vectors. Okay, the matrix that I'll call v1, v2, where v1 and v2 are these two basis vectors. Now, it's very important to understand this matrix and how this represents the situation. This is key to a lot of things that we're doing and we're going to do very soon. Okay, we'll go on with this in a minute.